Good afternoon to all. Sir, shall we start, sir?
Yes, madam. We can start.
Okay, sir. Pooja, Harita, start பண்ணுங்கப்பா.
Okay,
start பண்ணு.
Happy noon to all. Every day is a good day. There is something to learn, care, and celebrate. Welcome you all for the celebration of 133rd Ramanujan birthday. A day without prayer is a day without blessing. Now it's the time for silent prayer for few seconds. Thank you.
Few words about Ramanujan. Srinivasa Ramanujan Iyengar born on 22nd December 1887, who lived during British rule in India. Indian mathematician whose contributions to the theory of numbers include pioneering discoveries of the properties of the partition function. In 1911, Ramanujan published the first of his papers in the Journal of Indian Mathematical Society. Sunshine is a welcome thing. It brings a lot of brightness. Now I invite to deliver a welcome address by Miss S. Meena, 2nd M.Sc Mathematics.
A very good afternoon to one and all gathered here. On behalf of our college, I extend a very sincere warm welcome to all of you present here on the 133rd Ramanujan birthday celebration, National Mathematics Day, a function of our college. An equation means nothing to me unless it expresses a thought of God by Srinivasa Ramanujan. Stars shine at night. Some stars shine at bright daylight. It's our pleasure to welcome one such star, Dr.A.Felix, Assistant Professor of Mathematics, School of Advanced Science, Vellore Institute of Technology, Chennai campus, Chennai. Welcome you, sir. I would like to welcome the Secretary, Principal, Head of the Department and faculty members and my dear students. Once again, I welcome you all. Thank you.
Thank you, Ms. Yasmina. Dreams become a goal when action is taken towards its achievement. Now I call upon Mrs. M. Kavita Ma'am, Assistant Professor and Head of the Department of Mathematics, SF.
Good afternoon to one and all present here. Today, December 22, we are celebrating 133rd birthday of famous mathematician Srinivasa Ramanujan. His fascination with numbers and theorems started at a very young age, and he proved over 3,000 theorems and equations in his lifetime. Honoring his contribution, the country celebrates his birthday, December 22, as National Mathematics Day. I am glad to introduce our chief guest, Dr.A.Felix, completed his higher studies, UG, PG and Ph.D. in Loyola College. He received a Young Researcher Award in the year 2012 to 13, and also he received Maulana Abdul Kalam Azad National Fellowship Award by UGC by doing PhD. He published more than 45 papers in international and national level journals, and he gave more than 20 talks to the students on various topics. He published 3 books, and also he is the reviewer for the journal in the Springer. Under his guidance, 4 people are doing PhD. On behalf of our department, I thank our management and principal sir for give the permission to organizing this guest lecture program, and also I thank our chief guest for accepting our request to present this lecture. Students, listen carefully and utilize your further studies. Thank you.
Be grateful, ma'am. Excellence is not being the best, it is doing your best. I kindly invite Dr.A.Felix, sir, Assistant Professor of Mathematics, School of Advanced Science, Vellore Institute of Technology, Chennai. Welcome you, sir.
Thank you. Thank you, madam. Thank you, my dear student, for your wonderful introduction about me. On commemoration of 133rd Ramanujam birthday, I'm delighted to meet you all through this webinar. At the outset, I would really thank the Rajapalayam Raju College, Rajapalayam, Department of Mathematics, the head of the department, Professor Kavita, and all the faculties of the Department of Mathematics for providing this wonderful opportunity. And I personally thank all the organizing secretaries, and my special word of thanks to Dr. L. Bakiraj. And also I thank the principal and vice principal of this college for providing this wonderful opportunity. So let me share my screen. Is my screen visible?
Yes, sir.
Yes, sir.
Yeah, thank you. Today, I'm delighted to talk on an intuitive interpretation of AX is equal to B. So before I begin my presentation, let us recall the Ramanujam. He claimed, an equation means nothing to me unless it expresses a thought of God. We, the mathematicians, should look the equation as not as an equation. Behind, there are a lot of patterns are there, a lot of the beautiful things are there. So we should look at how we view the flower. Like that, we should view the equation. So once you started to view, and we really admired and we really appreciate the equations. Today, the talk will be on, of course, AX is equal to B, in which the following things are going to be seen. A geometrical view of AX is equal to B, and least square approximation when B is not in a column space. The famous problem, eigenvalue problem, in which page rank algorithm is going to be seen, and cryptography, and some of the applications of AX is equal to B. Okay. So what is linear algebra? So linear algebra is a study of vectors and linear transformation. Okay. So before we go into the linear transformation in lower classes, right from the 10th standard, we are dealing with the matrix. So we know the matrix, we have been taught the matrix as the is a set of all array of numbers, row and numbers, which is arranged in the form of rows and columns. This is what we are taught and we have seen as a matrix. But today we are going to view this matrix in a different form. This matrix, we are going to view this as a set of vectors. So whatever you have the entries, which we are not seeing as a numbers, as an array, we will be look at them as a vector form. We will be looking them as a vector, and then we will be seeing this matrix as a transformation. Okay. So as a transformation. So linear algebra is a study of vectors and the linear transformation. So, so before let me go into that, where this linear algebra has been used. Without knowing, we are using linear algebra in our day-to-day life. Even when I was some 12, 13 years old, one of my grandparents from my village, he posed this puzzle. This puzzle you might have heard. He said like this, I'll give 100 rupees to you. I need 100 goat. I need 100 goat. In the market, the goat prices are male goat, 10 rupees, female goat, 5 rupees, and baby goat, 50 paise. Baby goat, 50 paise. Okay. Then he asked me to buy 100 goat exactly for 100 rupees, and I should buy all the three combination, all the three, male, female goat, and baby goat. Then how many male, female, baby goat I would buy, provided that I should not have a remaining any amount. I should get 100 goat exactly for 100 rupees. Then how many male, female, and baby goat that I will buy. So this is the puzzle he has posted to me. Just I was some 13 years old. I was doing 8th standard. But at the time, I was not able to answer for it. And later, and then he has given an answer to me. Later, when I came to college, I was thinking about this, how this can be solved mathematically. Then I realized, so let us take this male, female goat as XYZ. Let us take XYZ. The first condition is the sum of these three goats should be 100 in numbers. X plus Y plus Z is equal to 100. I need 100 goats, provided that I should have all the three goat. And then the cost of the goat is 10 rupees male, 5 rupees female, and 50 paise baby goat. So for making the cost, 10x plus 5y plus 0.5z is equal to 100. Solving this two equation, we will get the solution what he has posted, the puzzle to me. And here we have a three variable, two equations. We have three variables and two equations. And we have studied the system of linear equation. When you have equation less than the number of variable, then we have infinitely many solutions. So we have seen this infinitely many solutions. Such cases, we can have infinitely many solutions are possible for this. But one of the solution is x is equal to 1, y is equal to 9, and z is equal to 90. So 90 into 50, 45. 55 is 45, 9 5s are 45, 1 10s are 10. So altogether 100. Okay. So this is one of the solutions. Since it is the living things, we can give it in terms of the integer form. So 1990 is one of the solution for this system of equations. So I would buy 1 male goat, 9 female goat, 90 baby goat. So you can also get the infinitely many possible solution out there. But I was wondering, when I was looking about this equation, I was thinking, who taught this system of linear equation to the grandparents who were illiterate? Even yes, he didn't go for the school, but he was able to give the system of linear equation. So we are living with this mathematics concepts without knowing it. Okay. So look at the beauty behind it. So let us also see some of the examples on the system of linear equations. Okay, so one more examples. Suppose in your surrounding, Rajapalayam, maybe the North Indian people and South Indian peoples are living. Let us consider. And usually, the North Indians would prefer the wheat. Okay, so we prefer rice. So what one of our friends does, they are making some shop. Okay, so in which he makes two packs. One is the south pack, another one is the north pack. At the south pack, it consists 5 kilogram of rice and 2 kilogram of wheat. Whereas at the north pack, 2 kilogram of rice and 5 kilogram of wheat. Suppose my mother asked me to buy 19 kilogram of rice and 16 kilogram of wheat. Okay, 19 kilogram of rice and 16 kilogram of wheat. Then how many pack you would give to me? Okay, how many south and north pack you would give to me so that I would get the 19 kilogram of rice and 16 kilogram of wheat. Okay, so after making this, I need 19 kilogram of wheat and 16 kilogram of rice. He has only 2 pack. What is this? 5,2 plus 2,5. These are the 2 packs. I want to find out what is my A and B. Okay. So here what we are doing here, 5,2 is taken as a vector form. So here we are writing this as a linear combination for this 1916. I want to find out what this A and B so that I get 19 and 16. This you can also, let us take instead of a, I'll take it x comma y. If you express this as an equation, so what is it? The vector addition 5x plus 2y, this is equal to 19. And the second one is 2x plus 5y, this is equal to 16. Solving these two equations, we will get the solution. So after solving this, we can check. So 2 comma, hello. So solving this, any one of the method, 3 comma 2, we will be obtaining. So what the shopkeeper will do, he will give 3 south pack and 2 north pack, he will give it to me. Okay. So you can see this 3, this is 3, this is 2. 3 5s are 15, and then 2 2s are 4, 19. Similarly, 3 2s are 6, 5 2s are 10, 60. So 3 north pack, south pack, and 2 north pack you would offer to me. Okay. Suppose I need 34 kilogram of rice, 1 kilogram of wheat. 30 kilogram of rice and 1 kilogram of wheat. Will he able to satisfy me with these two packs? Definitely he cannot. He cannot satisfy these two. And if he wants to satisfy, then what he needs to do? He needs to remove the pack, and then he needs to give the 1 kilogram of wheat to me, and remaining he put it over there. So this is, he may not do that because he packed. So he won't do that. He cannot satisfy me. So with this 2 comma 5 and 5 comma 2, he cannot satisfy everybody. Suppose someone needs 20 kilogram of wheat, rice, and 19 kilogram of wheat. He cannot satisfy this. Okay, because he could not remove this, isn't it? Suppose instead of this, if he makes 1 kilogram of wheat, 1 kilogram of rice, 0 kilogram of wheat, 0 kilogram of rice, 1 kilogram of wheat. If he makes a pack like this, then whatever kilogram of wheat, whatever kilogram of rice you need, you will satisfy this. Okay. So let us come back this. So let us draw this 5x plus 2y as this is the system of linear equation. Okay. So here the coefficient matrix 5 2 and 2 5. This is the coefficient, and the unknown variable is x comma y. Let us take this a capital X, and then 19 comma 16, that is your bi. Okay. So here what it means, so you will be getting ax is equal to b. Ax is equal to b, isn't it? The above, this can be expressed as ax is equal to b. Any vector, this vector x comma y, if you transform this matrix 2 comma 5 and 5 comma 2, transform this vector, you would get 19 16. Let's see that. Okay, so after solving this, we have found this is the solution. We obtain 3 comma 2. If we express this in terms of the vector form, vector can be denoted like this. Okay, this is 3 comma 2. This is the vector 3 comma 2. Okay, so A is your matrix. A is 5 2 2 comma 5, and your B is x comma y. Sorry, x capital X, and B is 19 16. Okay, this is ax is equal to b. Then what is, how we can view it? This ax is equal to b. Transforming this vector x, if you transform this vector ax, you should get this 19 and 16. 19 somewhere here. So let us take. Okay, let us take this figure. Yeah, okay. Yeah, 19 is, this is the 19. This is 2 comma 3. This is the vector. Sorry, 3 comma 2. And the 19, this is the 16. 19, 16 will come over here. So this is the vector. So consider this is x, this is your b. 19, 16. If you transform this vector 3 comma 2 through the matrix A, your matrix is 5 2 2 5. Through this, if you make it, you will get 19 16. So this 3 comma 2 is transformed through my matrix A to get 19 16. Okay, we can also view this matrix as a transformation. This 3, 2 is transformed to get a 1916 through this 5, 2, 2, 5. Okay, and then in order to get back this is Ax is equal to B. I need to get my X. How can I do this? A inverse of B. A inverse B. So this 1916 is transformed through A inverse. I can get 3, 2. I can get back my 3, 2. So this matrix can be viewed as the transformation. So we have that Ax is equal to B by solving this. When do you say the system is consistent, inconsistent? That we know this, we have studied. What is this? The system is consistent if the system has the solution. If the system has at least one solution, at least one solution. Inconsistent, the system has no solution. What are the possible solutions are there? Unique solution, no solution, infinitely many solutions. These are the possibilities are there. Okay, this is what we have learned in the system of linear equation by solving Ax is equal to B. Okay, but what are the applications are there? That also we are going to view this Ax is equal to B with a different perspective. Ax is equal to B. If this B is not in a column space, what will happen? If this B itself is X, then what will happen? Then these are the things we are going to see in this lecture. So only we are going to view this Ax is equal to B so deeply to get the real meaning of this Ax is equal to B. Okay. So that we have taken 5, 2, 2, 5. These are the two facts that we have taken. Okay. So again, okay, before we move on to this, let us, you have the system. Okay, we have the system. Ax is equal to B. We have the system. After solving this, 1 minute. Okay, fine. So after solving this Ax is equal to B, we have got a solution set. We have got the solution. That solution set I have viewed as the vector. Everything we are looking that as a vector. So the matrix you have, that matrix should be viewed as the vector. Okay, you have solving this, you got a vector, the bunch of vector you have. So let me call this as the V. Now is a set of vectors. With this vector, what we can, extended. Here, if you bring some operation, addition, vector addition, and scalar multiplication, if you bring these two operations and satisfies certain properties, then this set becomes the vector space. So vector addition, you know this, what is it? Take any two vector. So let us take, so this is, consider you got everything, the vector is 2 by 2 form. Okay, so you have a vector with the 2 dimension. Okay, r square you have considered, this is r square you have taken. V1 is one vector you have taken, this is V1, another vector V2. Let us take, this is V2. Adding these two, you will get, this is V1 plus V2. The resultant should be in your set itself, closure under addition. Take these two vector V1 and V2, adding these two V1, V2, the resultant should be in the set itself. So that's what we have learned. Adding these two vector, we obtain this, it holds the parallelogram. So V1 plus V2, this is the vector addition. And scalar multiplication, you take one vector, take some scalar, and multiplying this, it would be either if it is positive, it would be stretched or shrunken. So this will be alpha of V1. This is the scalar multiplication. So at the vector space, at the set of vectors, you will be using the vector addition and scalar multiplication. These are the two operations, and it holds certain things. V plus forms an abelian group, and V scalar multiplication holds, what is that? Closure and under scalar multiplication, distributive under vector addition, distributive under scalar addition, and then associativity, unitary operation. These are the laws holds good, then you can call them as the vector space. Okay, this vector space can also be extended by the inner product space by using the operation is inner product. Along with the vector space, if you are using one more operation inner product, then the vector space forms the inner product space. That we know this, we have learned. Okay, now you have these vectors. Here you want to check whether the vector is linearly independent, dependent, basis, and all. We have learned. What is the meaning of it? That also we will view it. But look at there, what we have taken origin only from this Ax is equal to B, from where we have been dealing. Okay, Ax is equal to B. Okay, the same vector, let us take 5, 2, 2, 5 is linearly independent or dependent. So if you draw this graph, 2, 5 and 5, 2. So consider this is a 5. Similarly, this is 5. This is 2. Let us take. Okay. The first vector, what is this? X is 5 and y is 2. Okay. So this is the first vector. This is 5, 2. Another vector, 2, 5. X is 2, y is 5. Okay. These two vectors are not lying on the vector itself. Okay. So this is the linearly independent. Even if you take in terms of the matrix form 5, 2, 2, 5, if you take the determinant will be non-zero, 25 minus 4. So this is non-zero. The set of vector determinant of the set of vector is non-zero. Therefore, this is linearly independent, this vector, because no vector depending on other vector. Okay. So V1 is not depending on V2. So if I take this vector 5, 2, 10, 4, these two vector I want to check whether this is linearly independent or dependent. If you draw the graph, let us take this is 5, this is 10, 2, and 4. Okay. So the first one is 5, 2, and second vector will be 10, 4. It lie on the same, it's in the same vector. This is V1 and V2. Look at this, V2, V1, V2 lie on the vector of V1. So therefore, this 10, 4 is depending on your 5, 2. It depends on your 5, 2. So therefore, this vector is linearly dependent. If you want to, you can take this 5, 2, 10, 4. So take this, 5 4s are 20 minus 20. The determinant is 0. Therefore, this is linearly independent. These are the properties you have seen. Okay. So, and this vector space, you will be learning whether this forms a linearly independent or dependent. One more term also you have learned, the basis. Okay, the basis also you have learned. Okay, so basis, you know this. The set of vector forms a basis. One, you will be taking some vector forms a basis, some vector you will be taking. If it is basis, then what will happen? We are able to express as the linear combination. Any vector from the set we have taken can be expressed as a linear combination, and second one, that should be linearly independent. If it holds, then you can call them as the basis. Okay, so 5, 2, 2, 5 is a basis or not? Yeah, yes, of course, it's a basis. But the thing is, for the shopkeeper, he cannot satisfy everybody with these two packs. Instead, if he makes 1, 0, 0, 1, so look at this. If he makes the pack like this, any kilogram of wheat, any kilogram of rice he needs, he will satisfy. So the meaning here is, if I want to generate any vector from my R square, if I want to generate this vector x, y, I can generate this through this vector 1, 0, 0, 1. I can express this, any vector can be expressed a linear combination of 1, 0 plus 0, 1. And of course, this 1, 0, 0, 1 is a linearly independent. Any vector I can express the linear combination. So therefore, it forms this is basis. Okay, basis. Okay, great, fine. Now, so we know this, the span, we know the span is the linear combination. The set of vector, the span of this vector, whatever the vector you have, okay, it will provide some vectors. With this vector, I can express the linear combination. Okay, this I can express the linear combination. So you have a matrix. The same matrix I've taken. This A, let us take. So Ax is equal to B. This A, let us take. A is the some m by n matrix. Okay, this is the m by n matrix, which means this will be in R power m by n. Okay, which means you have R power m and then Rn. This will be combined. Rm, Rn. Okay. If I take only the row vector and column vector separately, and also we will discuss. Okay. So here you take the row vectors R1, R2, Rm, C1, C2, Cn are the row vector, column vector. This is the row vector. This is the column vector. Here we are going to make a space, row space and column space. For the space, we need a basis because if you want to generate a vector, you need a basis. So here, if you span this R1, R2, Rm, okay, that will give the row space. So this row space R of A will be in your R par M. R par N, sorry, this will be in your R par N. Whereas the column space is the spanned by the column vectors. This will be in your R par N. I'll tell you why we have taken this row space and column space. So look at this. If Ax is equal to B, if we have, you can have a solution. Look at this. Ax is equal to B, you have. Provided this, your B should be in your column space, C of A, column space. You take a column vector, span of the column vector, that is a column space in which your B should be there. If B is there, then you can have a solution. You can have a solution. Got it? At Ax is equal to B, the B should be in your column space. Suppose if B is not in the column space, B is not in the column space, then can we have the solution? No, we cannot have a solution, but we can provide the partial solution. We can provide some partial solution. We can provide the pseudo solution. When B does not in a column space, when the system is inconsistent, we are able to find out the pseudo solution. So that's what we are going to do now. So far you have learned Ax is equal to B and you can have the solution. Okay. So if B is not in a column space, if the system is inconsistent means no solution. At this situation, can we find the solution? Yes, we can find the solution through the D-square method. So in this second part, we will be learning on how we can determine the solution when B is not in a column space. Okay. So look at this. Suppose one of our M.Sc friends who started a business. Okay. So he has these are the profits: 10, 8, 9, and 11 crores. So this is for quarterly. So the first quarters 10 crores, second 8 crores, 9 quarterly 9 crores and 11 crores. But now he wants to review what would be the income in the next year. So what he does, he call all the expertise of his company and he asks them to what would be the income for the next year. So he asks them to forecast. Okay. So first thing what we need to do that we need to fit them in the data points. We need to fit this. The first quarter he got 10 crores, and the second 8 crores, third 9 crores, and the fourth quarter he obtained 11 crores. Now we need to frame an equation that fit the data, okay, data points. So suppose if we make this is linear equation, y is equal to Ax plus B, some equation, linear equation. With this linear equation, we can approximately fit this data points. Okay, these are the data points we have. This is obtained from the company for the 1 year he has obtained. Okay, so through this, if he makes this equation, then we can forecast a thing. Okay. So what are the points? This is 1, 10. This is 2, 8 at the second quarter, and third 3, 9, and 4, 11. So if you apply this here, x is 1. This is x coordinates. Let us take this is y. If you substitute here, so what will happen? The first equation, 1x plus b is equal to 10, and the second equation, 2x plus b 8, because x is 2, y is 8. And then third is 3x plus b, sorry, a will come, x is, sorry, I'm sorry, 3a, 9, and the fourth one, 11, is equal to 4a plus b. Now look at this. Are you able to solve this equation? Definitely we cannot solve, because this, if you express this in terms of the matrix form, it will be like this. Yeah, you can have like this: A is equal to 1, 2, 3, 4, and beta coefficient is 1, 1, 1, and here capital X is alpha comma beta, and your B is 10, 8, 9, 11. This 10, 8, 9, 11 cannot be generated by the column space. So this B, which means does not in your column space. If you're, after some time, I'll share this PPT, you can also check whether the B is in a column space or not. M.Sc students, you might have learned the row space and column space, everything. When this B does not in a column space, you cannot have the solution. You cannot have the solution. But with the least square technology, we can find the solution. So look at this. Actually, this is our column space. Consider, if you draw this graph, you can have a plane. This is the column space. Actually, this B is not in your column space. If you draw the column space of this vector, okay, you can have a plane. This plane you have. And if this B in this plane, then definitely you can have a solution. The B does not here. B somewhere here. B is here. Okay. At this situation, what we can do? Here, you learn the projection concepts, projection. So what we are going to do, we are going to project this B in the column space, in this plane. You are going to project. How are you going to project? You are projecting a point which is very, 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 very closer to this B. If you take the distance between them is less than epsilon. Okay. So the aim is you are projecting this B in the column space. Okay. The distance between this point and this B will be very, very closer. So let us say this is X cap. This, how are you going to project? We are projecting through this normal equation. X bar is equal to A transverse, A whole inverse, and A transverse B. Okay, this B is transformed through this equation: A transverse, A inverse, A transverse, A transverse, A whole inverse, A transverse. Through this, what is this? This vector B is transformed to get your X cap. So this X cap will be the partial solution of the system. Partial solution of the system. Okay. So after solving, so this is what we obtained. Of course. So this is what? So 0.4, 8.5. This is the answer that we obtained. Okay. After fitting this, y is equal to alpha t plus beta, or alpha x plus beta. You will be getting 0.4x plus 8.5 y. Okay. This is the linear equation. This is the linear model for the data points. So through which we can forecast. Then what would be the fifth next year quarter would be the fifth term. Okay. So after substituting, you can get 10.5 crore in the next year of the first quarter. Okay. Through which we can forecast a thing. So here for this data points, the linear equation exactly fits. Okay, not exactly, approximately we are fixing. So we should not say this exactly. So we are in the world of going for the better approximation. Okay. So suppose if can we fit other than linear equation? So let us try this. So let us take y is equal to some quadratic equation. Let us take this quadratic equation. Alpha t square, beta t gamma be the polynomial that connects the same data points. Substitute, t is 1, y is 10. Similarly 2 2's are 4, 2 beta gamma is 8. Similar, the third point, 9 alpha, 3 beta gamma is equal to 9. Similarly, and after solving this, we obtain through the normal equation. Okay, 1 comma minus 4 comma 13.5. So with this, what happened? We obtain 18.5 crores. So look at this. So when you compare with the linear model, we are getting a lot of error here, okay. So for the given data points, the linear equation, the better approximation. So if we fit with that, definitely it won't be the better forecast. So it won't be the better forecast. Okay. So what we have done through this Ax is equal to B, we are able to when the B does not in a column space, we are able to give the partial solution. That is nothing but the least square solution. This is what you would have done at the statistics. You are fitting the regression equation, the regression for the forecasting, the predicting what will happen, okay, with the data. So here we have taken the Ax is equal to B. This is one of the way we can view this Ax is equal to B. Another one, suppose this Ax is equal to X. Okay, you transform this vector X through this matrix. The resultant would be the same vector itself. If you obtain, then how this problem can be tackled, how we can solve. Definitely, you learn the eigenvalue problem in your lower classes, eigenvalue problem. Okay, so let us view this. Ax is equal to B. Suppose my vector, my matrix is A is 0, 3 and 2, 1. I'll take one vector, X is 1, 1. Okay, let us take this. Okay, so let us take this vector, X is 1, Y is 1. So this is the vector. This is our X, this X. I want to transform this vector 0, 3, 2, 1. If you transform this, what will happen? Zero, 3, 2, 1, 1, 1. If you transform this, what is that? The resultant is 3, 2 plus 1, 3. So the resultant is 3, 3. So where this 3, 3 will be there? 3, 3. So this is 2, 3. Similarly 2 and 3. So this will be 3, 3. So this is the resultant. So what happened here? A, when you transform Ax is Ax, we obtain, what is that? 3, 3. This can be expressed as 1, 1, 3 times. This vector thrice, 1, 1 thrice. So Ax is equal to lambda x. This lambda is the eigenvalue. 3 is the eigenvalue. The corresponding vector is the eigenvector. So 1, 1 is the eigenvector for the eigenvalue lambda is equal to 3. Okay, so this is 1, 1, 3, 3. With this eigenvalue, if lambda is positive, then this vector is stretched. The lambda is negative. The vector is stretched in the negative side. Okay, this is the eigenvalue problem. With this, what we can do? Okay, the page rank algorithm, this eigenvalue problem is used. Suppose you are typing something in the Google. In the Google, you are typing Raju College, Rajapalayam. Suppose I'm typing Rajapalayam in the Google. The Google, I'm typing Rajapalayam. Okay. How the Google will identify this is the page should come first. What page should come first? When I type Rajapalayam, the related to the Rajapalayam, lot of web page will come, isn't it? It will come. How Google will identify this? This is the page should come first. This page should come second. This page should come third, and fourth goes on. So here, the page rank algorithm used to give the priority for the pages. Okay, so that let's see this. Of course, this page rank algorithm is proposed by Larry Page and Sergey Brin, who are the founders of the Google. Okay, so let us take, suppose I searched Rajapalayam. These are the pages we obtain. Of course, all the pages are connective to each other. Okay, they are connective to each other. So for example, we have taken only 1, 2, 3, 4 pages. But when you type Rajapalayam, you will be getting definitely more than 1,000 pages. More pages will appear with related to the Rajapalayam. Okay, so this is the page I obtained. Now, here the graph theory concepts can be used. So 1, 2, 3, 4 are considered as the pages, and the link is also given. And x1, how many incident edge the x1 is obtained. So 1, 2, x1 is obtained, 1, 2. x2, how many edges are incident at a node 2? Okay, it receives only 1, whereas the page 3, 1, 2, 3, 3. x4 is 1, 2, 2. Okay, so here the incident edge is taken as the importance of the web pages. Importance of the web pages. Now, we are going to express this as the linear combination. So first vector, let us take x1. How many vectors, how many pages are incident? So look at this, x3 and x4, these two pages are incident at 1. And for x2, only 1. Okay. For x3, x1, x2, x4. For x4, x2 and x1. Okay, so this is we obtain. But here we have taken only incident edges. The outer edge is not taken into an account. But here we are not omitting, we are also taking the outer edge. How many edges are leaving from the node 1? Look at this, 1, 2. At x1, 2 nodes are leaving. 1 and 2. x1, 2 nodes are leaving. Sorry, 1, 2, 3, 3 nodes. For x2, how many nodes are, how many edges are leaving? At x2, 1, 2. And for x3 only 1. At x3 only 1. At x4, 1, 2. So to take this outer edge, okay, taken into an account, the x3 will be divided by the number of edges is left. So x3 by 1, x4, 2 edges, x4 by 2, and x2 is equal to x1. 3 edges are leaving from x1. So x1 will be divided by 3. Okay. So this is we obtain. And after this, we are writing this in terms of the system of equation. The first one, x1 is equal to 0, x1, 0, x2, 1, x3, 1 by 2, x4. Similarly, everything we have framed in terms of the system of linear equation. And then here A is the coefficient matrix and the unknown variable x1, x2, x3, x4. This is x1, x2, x3, x4. So we obtain Ax is equal to x, which means here lambda is, which means lambda is 1. So what is this x? This x will be the eigenvector for your lambda. For your lambda is equal to 1. This is eigenvector for lambda is equal to 1. Okay. But here what we have to do, we need to find out the eigenvector for this lambda is equal to 1. So this is the matrix. In you will be dealing with only 3 by 3 matrices, 3 by 3 matrix. So you'll be finding the eigenvalue, eigenvector, everything you have done. For the corresponding eigenvalue, you will be finding the eigenvector A minus lambda I x. Okay, you'll be substituting your lambda, you'll be getting this vector, isn't it? By solving the system, you'll be getting this vector. But here our task is to find out the eigenvector for lambda is equal to 1. So with the MATLAB, you have found the value. The eigenvector for the eigenvalue is 0.72, 0.24, and 0.5408 and 0.3605. Okay. So if you look at it, the first page has got the value 0.7210. When you type the Rajapalayam, it may be the Raju College. The first one is the Raju College. Okay, the page may be the Raju College. That will appear first. The least would be the second page, 0.2403, whatever we have taken in the net. So so this is the Rajapalayam College. This may be the INR Falls. Okay, INR Falls, and so on. So the priority for the Google is the Rajapalayam page. The final one, the INR Dam. Okay. So using this, we can also find the we can use at the page rank algorithm. Okay, so far what we have learned, we have solved the least square problem through Ax is equal to B, and then we have seen Ax is equal to x when B is itself x. Okay, when you transform this x through this matrix, the resultant is same x itself x. Then what are the problems are there? So this is the page rank algorithm. This x we can obtain when this lambda is 1 for the corresponding eigenvector for the lambda is equal to 1. Okay, good. Now let's move on to the beautiful application, the cryptography. Okay. So this application is really, really interesting. We know the cryptography. So, and the undergraduate or postgraduate, you would have learned this cryptography. Okay. So crypto in the sense, you want to send a message secretly to the second person without breaking by the third person. You want to send the information secretly. That's it. How are you going to send secretly? Okay. So this is what we are going to learn, this cryptography through this Ax is equal to B. Okay. Okay, before going into the cryptography and how the crypto system were used in the olden days. Okay, so those days, you know, the war would be running more than a year and month. You know, if the king want to send any information secretly, how they would do, suppose they will find some soldier, the soldier head would be shaved and they will write the message on his head. Okay, so he has to wait till the hair comes back, and then you would be sent to the place where the war is going on. And suppose if he's caught by the opponent kingdom, then what will happen? They can easily steal the message. The message easily intercepted. So if they steal the message, then what will happen? They can win against the king. Okay. So that is also not secret. Okay. That is also, what is it? That is also a strong way of cryptography. Okay. That is those days they have done. That is not a strong, the first one. And later, you know, they've made this kind of ruler they have. Okay, suppose they have a ruler. If they want to send any information, they will rotate on it. One side, they will write an information. Suppose this is the message I want to convey. LOVE, this is the message. And remove it from the ruler, and you may have a space between them. You can fill it. Fill some letter, something we can fill. Okay, and this would be sent to the person whom want to share the information. And what he or she does, they will rotate the same ruler they will have. They will rotate and they see. On one side, they can get the information. What he or she friends send the message. Okay, this is also not a secret. If they have the same ruler, then they can also catch the information. So for this, to send the message strongly, what methodology we can go for it? So if we use some mathematical logic behind in it, you know, it would be strengthened. We can send the message secretly. Okay. For instance, suppose A, B, C, D or the alphabets. Okay. So what we have done, we are adding +3. If you add +3, what will happen? You will be getting D and E for this, and for B, C, D, E. Okay, we are using this. So what is this C and what is this P? Let's learn. Okay. So here I want to send the message. I want to convert into different form. Okay. So the plain text is converted into the cipher text. This is called N-cipher. Okay. So this is the, initially you have this is the plain text. The plain text is enciphered to the ciphertext. Okay, plain text, this is the enciphering. To decipher this from ciphertext to plain text. From ciphertext to the plain text. What, in order to get, this is the function they have used, f of p plus p plus 3. This is the plain text you have, whatever you have. Suppose I want to send this message love. So love the position L. So L is here, plus 3. 1, 2, 3. 0, sorry, O, and then O. 1, 2, 3, R, and then next is V. 1, 2, 3, Y. E is 1, 2, 3. H. So this plain text is converted into the ciphertext through this P plus 3. In order to get back, so what shall we do? We need to find out the inverse of it. So what is that? The F inverse of P is, you multiply F inverse on both sides, pre-multiply. F inverse of C is equal to, you can have, this is P, if you bring this minus 3, this is equal to P. So if you subtract from this O minus 3, O minus 3, go back, L, you'll be getting, and then R minus 3, O, you will be getting similarly this. So here we are using the shifting concepts or substitution cipher. Okay. This method is also called as Caesar cipher, Julius Caesar cipher. Okay. So for example, you can also, the Ramanujam, the letter is taken. This is a plain text. I want to cipher it. What is it? R is R plus 3. The same thing I have used, plus 3. STU. Similarly, A. 1, 2, 3, D. So this is ciphered. Okay, good. We have done plain text and the cipher text. And actually, this idea was given by the Caesar, Julius Caesar. Suppose he sent this message, attack. He conveys this message to the soldiers who are doing the war. So this is the soldiers taken. I told you, those days, you know what they have done. Suppose this attack is written on his head. Okay, so his head would be shaved. This information is written on his head. He has to wait till the hair comes back, and once it comes back, he can go to the place, and after shaving his head, they can read the information what the king has instructed. Fine, good. Suppose if he is caught by some other king, then what will happen? The message can be intercepted easily. And here the Caesar used the attack by using the mathematical concepts, using some shifting plus 3. Okay, plus 3. So if you do this, so here he has used plain text plus 3. F of P is equal to plus. So you obtain dw dfn just using the shifting concepts. But this shifting is also, easily they can steal the information. Okay, so this is also, not strengthened enough. Okay, so this is, we have said, encryption is plain text to ciphertext, from plain text to, decryption is from cipher to plain text. Okay. So you can ask, what is the meaning of the 3? So everybody will have some key. So like a phone number, how we have. Similarly, they have a key is the 3, through which they can move it. Okay, so he knows the inverse of 3, minus 3 under addition. Okay. Similarly, everybody will have a key. Okay, this is also not strengthened enough. Okay, so here all the alphabets are assigned numeral values under the modulo 26. Okay, under mod 26. So modular arithmetic, you know this, that you should be very good at it. Okay, so here this shifting concept is also not strengthened enough. So here the Hill cipher, Hill has introduced one of the ciphering system using the matrix AX is equal to B. So what he has taken, X is your plain text. Okay, plain text. A is some phone number, some matrix they will have. Okay, how we have a phone number like this, they have, everyone will have a matrix. Okay, some phone number or something, some 4 number will be there, that can be expressed as a 2 by 2 matrices, 2 by 2 matrix. Suppose some X is the plain text that transformed through this matrix A. The resultant will be done under modulo 26. Okay, so whatever, if you get more than 26, that will be divided by 26. Whatever the remainder it leaves, that will be taken. So this be the corresponding numeral value whose alphabets, the corresponding alphabets will be taken. This is the ciphertext. Is used the mathematics concepts. In order to get back the plain text, what we can do, X is equal to pre-multiply by A inverse of B. If we transform the ciphertext, you can get the plain text. This is the idea yes taken and yes made a ill cipher crypto system. Okay. So let us take this. So the process would be very simple. Suppose Professor Bakiraj has some number. Okay, this is his phone number 2 by 2, some 4 number, like how we have a password for ATM. Okay, 4 number, right? So that he has made it as the, that we generally we make it as the matrix. Okay, so 2 by 2 matrix. Okay, suppose for Bakiraj sir, I want to send this message, love. I want to send this message. So in order to multiply with the 2 by 2 matrix, what we need to do, we need to make it as a pair of numbers, We need to make them as a group, okay, as a pair. Suppose it has some odd numbers. Okay, this is loud. Suppose this is the message I want to send. So look at this here, I cannot make a pair since it is the odd number. So we are privileged to add some dummy numbers. We are privileged to add some dummy number. DD. Okay. And then what is it? The corresponding value L, you know this. L is L position. L is 11 and O is 14. B 21. E 4. Similarly for DD 33. Suppose LO. Let us take L is 11, 14. So this is 11 and 14. Yes, this is the number ES 1475. 1476, let us take 76. This is his phone, some number 1476. So what is this? Through this matrix, this 11 and 14 is transformed. Whatever the resultant that we obtain, we need to make it under modulo 26. Divide them by 26, whatever the remainder leaves, that is taken, and the corresponding the alphabets will be taken. Okay, this is step 2, step 3 as well. The corresponding would be the message which we need to convert. Okay, the same thing let us take. Suppose I want to convey this message, love. Okay, the secret key is 201537. This is someone's phone number. Okay, someone's. So yes, 201537. So I made it as the 2 by 2 matrix. Everyone will have the 2 by 2 matrix. Suppose I want to send this message to a person, to this person, some person. Okay. So LO 11 and 14. Transform this. This is the resultant we obtain. Under modulo 26, it leaves a remainder 2. 263 leaves remainder 3. So 2, 3, the corresponding letter is 2 is C, 3 is T. Similarly for this one. V position is 21, E is 4. Under this transformation, we obtain this. Under modulo 26, we obtain 16. 16 is Q, 5 is F. So what we need to do, I need to send this message CDQF. CDQF. Now, this is the message. I will send it to this person. So what this person will do, he will take, he knows his A inverse. So look at this, finding A inverse is easy job. For 2 by 2, you are able to do some 4 by 4, 10 by 10. Such matrix you have. If you have 10 by 10, what will happen? Then it is really, really difficult for us to find out A inverse. We can find, but it consumes a lot of time. It will take a lot of time on finding this A inverse. Okay. So he knows, this person knows already this A inverse. So what he will do, this is the ciphertext he obtained. So A inverse this ciphertext A inverse B. Through this, you can get the original message, plain text, I can get it. So let us see this. So CDQF, I want to get the encryption. Okay, the encryption is 2015. I want to get the decipher of this. So we need to find out the inverse of this. Okay, the finding the inverse we obtain is under the model 26, 519, 918. This is the inverse that we obtain for the matrix A. Okay, for this matrix 5, 9, 19, 18. So CD is 2, 3, transformed to this, and we obtain 11, 14. And then 9, 8, second one is QF 16, 5. Under this transformation, we obtain 21, 4. So 11, 14, 21, 4 is love. We got the message. Okay. So we enciphered a message. Encipher, you know this. Conversion from plain text to the ciphertext, whereas decipher is conversion from ciphertext to the plain text. We have got back the original. So what we have taken, only you have taken AX is equal to B. Still we are talking about your AX is equal to B. X is the plain text, B is the ciphertext. Okay, so this is transformed through this matrix, you get your cipher. And then to get back my plain text through A inverse, I can get it, A inverse B, through A inverse. You can ask me, can only 2 by 2, is it possible? No, it is possible for all the square matrix. Okay, for all the square matrices, it's possible. Suppose you have some 5 by 5 matrix. Everyone is given this 5 by 5 matrix. What is that? Some lengthy information you have. So that we need to make it as the 5 elements in a group. You need to make 5 elements of the group. Okay, this vector will be multiplied, transformed through this 5 by 5 matrix. Under modulo 26, whatever the remainder it leaves, that is taken, the corresponding, the alphabets will be taken, that will be sent to the person whom we want to send the message. Got it? This is one of the crypto system. So here people are also working more number of crypto system, RSA crypto system, so many crypto systems are there. So there where people are working on it. Here actually what we have taken, only we have taken our AX is equal to B. So we have taken the AX is equal to B and we are looking with a different view. So first what we have taken, this AX is equal to B, and we have discussed about the solution. You have the solution. If the solution set, what are the things we can do? Vector addition, scalar multiplication. And then from this, we have seen if X is not in your B is not in the column space, then what we can do? We have seen the least square solution. We have seen the least square solution. And then second one, the eigenvalue problem, Ax is equal to X. So when you transform this vector X to this matrix A, you will get your X. So this X is nothing but the eigenvector for lambda is equal to 1. So through which we have determined the eigen page rank algorithm. And the third, again, we have come back your Ax is equal to B. Through this Ax is equal to B, we can do wonders at the crypto system. Okay. So you can also ask, what are the other applications are there? There are so many applications are there at your for your linear algebra. Okay. So hereafter, we should look this A as the matrix as the vector. So you can view them as the vector form. You have a vector, and that should be viewed as the transformation. We can view that as a transformation. How we can view this as a transformation? You can ask. Okay, nowadays, mostly, our people are playing the PUBG, Free Fire, and all the games that we play. So behind this, what the mathematical logic, mathematical concepts are there. And if you look at this, I never played the PUBG and all, but behind this, what is there? I just browse and I got to know. Okay. So the linear algebra, the matrix theory behind is there. Okay. So suppose, let us take, you are playing in the R square, okay, the R square, you know that. Okay, suppose let us take a vector on any one of the vector. Let me take this vector 1, 2, 3. So 3, 2. This is the vector 3, 2. So you are here. Okay. So one fellow is here. You want to shoot here. You want to shoot or you want to project here. So then how you can do this? This is x is equal to 3, 2. Okay, 3, 2 in terms of the vector form. I want to project over here. The resultant should be, this will be, what is this? This will be 3, 0. This position is the 3, 0. I want to get this vector, or this person who stands there, he himself, or he wants to project, or he want to shoot the person or hide over here, 3, 0 at this position. How he can obtain? So 3, 2, he needs to get under some transformation, he needs to get 3, 0. Then what is the transformation that he can use? Okay. So if you use 1, 0 and 0, 0, 0 through this transformation, what he can come here? He can come here 3, 0. Okay. Suppose he himself project over here. Yeah, this point is, this is -3. Sorry. Yeah, this is -2. Sorry, -2. And this is 3. Yeah, 3, 2. So this point, 3, -2. I want to get this fellow, this vector 3, 2 should project over here. Then what is the transformation he can use? 3, 2, 3, -2. So he can use the transformation 1, 0, 0, -1. But this, through this transformation, he can. So suppose this side, this will be -3, 2. This vector I want to project over here. Then what is the transformation? We can use it. So we can use this 3, 2 to get this -3, 2. You can use the transformation -1, 0 and 0, 1. Through this transformation, you can get this. So this is the ideology, even the rotation. So rotation can be done. Suppose I want to rotate this vector 3, 2 for 45 degree. How I can do this? This matrix cos theta, sin theta, and minus sin theta, cos theta. Through this orthogonal matrix, we can do this. So through this matrix, you can rotate at what degree I want to rotate, pi by 2 or something. Okay. So you'll be finding theta is pi by 2, whatever the value obtained, that 3, 2 will be transformed. The resultant will be the rotation of 3, 2 with the 90 degree. Okay, if you rotate 90 degree, you may have the resultant. So these are the ideas are behind in the PUBG and Free Fire. Even adding 2 vectors, vector addition, scalar multiplication, everything is there. So those people, I hope this mathematics students won't play this kind of the game. Instead, they will explore more. They will search more on what is the mathematical concepts behind there. And once if you explore to know, you will really appreciate, and you will appreciate the the happiness behind it. Okay, so there are a lot of applications are there, especially graph theory, game theory, data science, neural network, everywhere. So the concepts of linear algebra. Okay, so nowadays, this linear algebra is very well used as the deep learning. That current trend is the artificial intelligence. Artificial intelligence. We know this. Artificial intelligence. We are trying to make a system which mimic what human thinks. Suppose, even the medical diagnosis. So at our rural side, doctor may not easily available, isn't it? Doctor, we cannot get the expert doctor, medical practitioner in the rural background. Instead, what they are trying to do, definitely the expert doctor who are in the urban, all their knowledge will be combined and make the the system, artificial intelligence system. Okay, so they are making a system with the help of all the experts, and they are keeping it. Okay. At the artificial intelligence, then linear algebra, probability theory, and your multivariable calculus. Multivariable, the calculus and linear algebra plays a vital role. Okay, so at the data science, the linear algebra plays a lot of role. Even at the MATLAB, if you learn this software, MATLAB, Matrix Laboratory, MATLAB, this is the software for solving mathematics related problem. Initially, this MATLAB was proposed only for solving the linear algebra problem, eigenvalue problem, only solving the system of linear equation and eigenvalue problem. They've designed this MATLAB in the early 80s. And later they have incorporated all the mathematical concepts, and now it is one of the best tool. Okay, so most of the mathematician people and other engineering discipline people are using. So whenever we are not able to find the solution, when it consumes a lot of time, this tool we have using this, you can. Okay, so my advice to the M.Sc student, if you want to pursue the higher studies, want to do further research, please learn MATLAB and then R. R is one of the tool. R is for statistics. R is for the statistics. This is for mathematics. Okay, especially for the people who are doing the fluid dynamics, research on fluid dynamics, where they got a lot of differential equation, higher order differential equation. Solving manually, it consumes a lot of time. But if we have these tools with this, we can solve it easily. Okay. So at the artificial intelligence, linear algebra, probability theory, multivariable calculus are used. You should be very good at this. Okay. And of course, this MATLAB also designed with regard to the matrix. And if you look at this MATLAB is the matrix laboratory. Okay. So whatever you type, that will read as the vector form. That will read as an array. Okay. So MATLAB, you can learn it. So finally, I want to conclude. Linear algebra is the mathematics of the data. Okay. Nowadays, the current trend is going to be the big data analysis, data analytics is going to be. So whatever the information you take, you have a lot of information when you want to know anything. So with the bunch of data, so what you can do? Some analyst should be there to take a meaningful decision. So you have a data, only data you have. Okay. With the data, what you can do? If you want to forecast, if you want to take a decision, you have some data. You collected some data on this COVID-19, the impact of COVID-19. You got it. You collected data. With the data, can you take any decision? So nowadays we have, initially, all the countries were completely locked down. Why? Because of the impact of this COVID. They got a lot of information on COVID from the advice of WHO. All the countries were shut down, and after some time, we have given some relaxation. So why? They've collected the data for 6 months, and then whether we can open, whether we can relax, whether these rules can be implemented, we need to take a decision. How? Some analysts should be there. Some mathematical concepts are applied over here to take this particular decision. So the expert is nothing but your mathematical model. Okay, so the linear algebra is the mathematics of the data. Matrices and vectors are the language of the data. Okay, so whatever we have said, even if you frame a data in terms of the matrix form, and that we call it as the language of the data. Linear algebra is a valuable tool in all the branches of the mathematics, especially in statistics. Even we have tackle a problem, least square, through the linear algebra. The same problem we would also be dealing at the statistics. So for my talk, I've taken, these are the 3 references, and thank you so much for your patient listening. If you have any questions, I'm happy to answer.
Education is the most powerful weapon which you can use to change the world. It's very kind of you, sir. Thank you, sir.
எனக்கு
Saying
but
thank you is more
no
than...
no Arita, I need somebody should interact with me. So my dear students, please, if you have any further doubt on your further studies, you can ask. I'm really happy to answer. Anyone? Any two? Harita, before you conclude vote of thanks, can you ask any question? Or have you understood anything, my dear? Ramya, Vijalakshmi, Kalpana. Okay.
ஸ்டூடெண்ட்ஸ் ஏதாவது கொஸ்டின்ஸ் இருந்தா சார் கிட்ட இன்டராக்ட் பண்ணுங்கப்பா.
யா, நீங்க கேளுங்கம்மா. ஐம் சாரி, ஏதாவது கேளுங்க. உங்களுக்கு ஃபர்தரா என்ன நெக்ஸ்ட் என்ன பண்ணணும், எதுவா இருந்தாலும் கேளுங்க. ஐ எம் ரெடி டு ஆன்சர். இல்லை எது இது எனக்கு புரியல, இது சொல்லுங்க அப்படின்னு கேளுங்க. பயப்படாதீங்க, தயவு செய்து வந்து நம்ம மேத்தமெட்டிக்ஸ் ஸ்டூடெண்ட்ஸ் எதுக்குமே பயப்படக்கூடாது, சரிங்களா? ஹலோ, அண்ட் ஒன் மோர் திங்க், இதை வந்து நான் சொல்லி ஆகணும் மை டியர் ஸ்டூடெண்ட். யூஸ்வலாக வந்து நம்ம மேத்தமெட்டிஷியன்ஸ்க்கு வந்து எப்பயுமே ஒரே ஒரு என்னன்னாக்கா, நமக்கு இவ்வளோ லாங்குவேஜ் போதும், இதுக்கு மேலே வேணாம், நம்ம என்ன மேத்தமெட்டிக்ஸ் தானே, ஈக்குவேஷன்ஸை சொல்ல போகிறோம், எதுக்கு லாங்குவேஜ்லாம் வேணும் அப்படின்னு நம்ம நினைப்போம். தயவுசெய்து அந்த மாதிரியான ஒரு திங்கிங் இருந்தால் நம்ம எடுத்துடலாம். ஏன்னா இது இல்லை, எல்லா இடங்கள்லையும் இருக்குது. எங்களுக்கு கூட, ஈவன் நான் ஸ்டூடெண்ட்டாக இருக்கும்போது கூட, செமினார் எடுக்கும்போது கூட பார்த்தீங்கன்னா, சே இவ்வளோ எடுத்தா போதும், நமக்கு எதுக்கு இங்கிலீஷ், அதெல்லாம் தேவையில்லைல்ல அப்படின்னு சொல்லிட்டு, நம்ம என்ன ஈக்குவேஷன் தானே, y is equal to f of x, from that we can இது கிடைக்கும் அப்படின்னு நம்ம சொல்லிட்டு இப்படியே இருப்போம். நம்ம அதெல்லாம் அவாய்ட் பண்ணிக்கோங்க. நிறையா கற்றுக்குங்க, நிறையா லேர்ன் பண்ணுங்க, நிறையா படிங்க. மேக்ஸ் ஸ்டூடெண்ட்ஸ்னாலே ஒரு கெத்து தான் வச்சுங்களேன். உண்மையிலே இன்னைக்கு கூட என் ஸ்காலர் கூட சொல்லிட்டு இருந்தேன், இன்னைக்கு நேஷனல் சயின்ஸ் டே இல்லைங்களா, பேசிட்டு இருந்தேன். சார் மேக்ஸ் நம்ம ஒரு பயங்கர ப்ரௌட் தான் இல்லை, மேக்ஸ் ஸ்டூடெண்ட்டு மேக்ஸ் படிக்கிறது அப்படின்னு. ஸோ நம்ம தான் உண்மையிலே ஒரு பிளஸ்டு பீப்புள் நம்ம சொல்லுவோம் மேத்தமெட்டிக்ஸ் படிக்கிறது. இன்னும் ஒரு சில கண்ட்ரிலாம் போனீங்கன்னா, இந்த கொரியன் அங்கெல்லாம் பார்த்தீங்கன்னா, மேத்தமெட்டிக்ஸ் டீச்சரையோ இல்லை மேத்தமெட்டிக்ஸ் ஸ்டூடெண்ட்ஸ் வந்து தே வில் திங்க் தே ஆர் காட் அப்படின்ற மாதிரி திங்க் பண்ணுவாங்களாம். ஏன்னா நாம தான் நிறைய கிரியேட்டரா. ஸோ நேச்சர், இந்த உலகமே வந்து பார்த்தோன்னா நேச்சர் ஆஃப் த லாங்குவேஜ்னு சொல்லுவாங்க. இங்கே சொன்னாலும் ஒன்னாலும் ஒன்று தான், அங்கே மற்ற லாங்குவேஜில் சொன்னாலும் அதே தான். ஸோ மேத்தமெட்டிக்ஸ் வந்து நேச்சர் ஆஃப் த லாங்குவேஜ், அந்த லாங்குவேஜை நம்ம படிக்கிறோம். ஓகே, உலக மொழியை நம்ம படிக்கிறோம். ஸோ உண்மையிலே சொல்லுங்க, நம்ம பிளஸ்டு பீப்புள் தானே? இதுக்காக சொல்லுங்க. ஹலோ, இல்லை ஏதாவது கேளுங்களேன், ஏதாவது ஃபர்தரா ரிசர்ச் பண்ணலாமா, இல்லை என்ன ஏதுன்னு கேளுங்களேன். கேட்டிங்கன்னா நான் உண்மையிலே ஹாப்பி. இன்னொன்று நல்லா கவனிச்சிங்க, தயவு செய்து என்றைக்குமே வந்து நம்ம கேட்கறது தப்பா இருக்குமோ ரைட்டா இருக்குமோ என்றைக்குமே யோசிக்காதீங்க. அப்படி நினைச்சிங்கன்னா நம்ம கற்றுக்கவே முடியாது. அந்த தாட்டை முதல்ல உடைங்க. தப்போ ரைட்டோ கேளுங்களேன். சின்ன வயசுல குழந்தை எப்படி பேசும்? எப்பமா வந்த, என்ன சொல்லும்? நாளைக்கு வந்தேன் அப்படின்னு சொல்லும். எப்பமா போற, நேத்துக்கு போறேன் அப்படின்னு சொல்லும் இல்லையா? தப்பா பேசும். நம்ம என்ன பண்ணுவோம், அம்மாவோ இல்லை அப்பாவோ டீச்சரை என்ன பண்ணுவாங்க, ரெக்டிஃபை பண்ணுவாங்க. இல்லை இப்படி பேசக்கூடாது, இப்படி பேசலாம். குழந்தை எதை பத்தியும் பயப்படாது. தேவில் என்ன கேட்குதோ அதை பேசும் ஜாலியா. ஸோ அந்த மாதிரி இருங்க. நிறைய கேளுங்க, டீச்சர்ஸ்களை கேளுங்க. உங்க ஹெட் ஆஃப் த டிபார்ட்மெண்ட் மீனா மேம், அப்புறம் வாக்கிராஜ் சார் இருக்காங்க, இன்னும் எத்தனை ப்ரொஃபஸர்ஸ், அவங்கெல்லாம் அப்ரோச் பண்ணுங்க. உண்மையிலேயே வந்து ஐம் ஹாப்பி. இத்தனை நாள் நான் நிறைய இன்வைட்டட் ஆக கொடுத்தாலும் உங்க கூட இன்ட்ராக்ட் பண்றது எனக்கு ரொம்ப ரொம்ப சந்தோஷமா இருக்கு. நீங்க ஏதாவது கேட்டீங்கன்னா ஐ வில் பி டிலைட்டட், ரொம்ப சந்தோஷப்படுவேன். இன்னொன்று ஒரே ஒரு விஷயத்த மட்டும் நான் சொல்லிக்கிறேன். நான்லாம் வந்து ஒரு மேத்ஸ் ப்ரொஃபஸராக ஆகணும்னு நான் யோசிக்கவே இல்லை. சார் பாக்கியராஜ் சார், கேன் ஐ இன்டராக்ட்? நான் பேசலாமா மேம், மீனா மேம்?
எஸ் சார், எஸ் சார்.
ஓகே, தேங்க்யூ மேம். நல்லா வந்து 10th வரைக்கும் நல்லா மேக்ஸ் பண்ணுவேன். 12th எல்லாம் அந்த அளவுக்கு எதுவுமே தெரியாது. ஏதோ அப்படிதான் இருந்தேன். உண்மையை சொல்லணும்னா நான் லாயலா அந்த பக்கம் போன பிறகுதான் நான் மாறிக்கிட்டேன். நான்லாம் ரொம்ப சாதாரண ஒரு குக்கிராமத்துல இருந்து தான் வந்தேன். எங்களுக்கு அந்த ஒரு ஆப்பர்ச்சுனிட்டி இல்லைன்னா நாங்கெல்லாம் நல்லா வந்திருக்க முடியாது. ஸோ அதனால உங்களுக்குலாம் ஒரு நல்ல ஆப்பர்ச்சுனிட்டி கிடைச்சிருக்கு. எம்எஸ்சி எல்லாம் படிக்கிறீங்க, மேக்ஸ்லாம். ஸோ ஈவன் யூஜி வரைக்கும் நான் என்ன நினைச்சேன், நம்ம தான் பிஜியா படிக்க போறோம், அடுத்து சாஃப்ட்வேர் லைன்ல ஏதாவது எம்சிஏ முடிச்சுட்டு அப்படி போயிடலாம் அப்படின்னு நினைச்சிட்டு இருந்தோம். அதுக்கப்புறம் பிஎஸ்சி பண்ணோம். ஏதோ ஒரு சில சப்ஜெக்ட் மட்டும் பிடிச்சது, அதை மட்டும் படித்தோம். மீதி நான் கொஞ்சம் டெப்த்தாக படிக்கணும்னு நினச்சா கூட ஃபர்தராக நான் என்ன மேக்ஸாக படிக்க போகிறோம், போதும் மார்க் எடுத்தால் போதும் அப்படின்ற மைண்டில் இருந்தது. அதுக்கப்புறம் எம்எஸ்சி வந்து ஆக்சிடென்ட்டாக தான் போச்சு எனக்கு. ஒரு 1 month நான் எடுத்த டெசிஷன் கரெக்டாக, நமக்கு ஒன்றுமே தெரியாது என்னடா பண்ணுறது அப்படிதான் இருந்தேன். அதுக்கப்புறம் 1 month என் ப்ரொஃபசர்ஸ் கேட்டாங்க, என்னடா எப்படி ஏன் அப்படி இருக்கு அப்படின்னு. இல்லை எனக்கு ஒரு மாதிரி இருக்கு. ஈவன் நான் ஃபர்ஸ்ட் செமினார் எடுக்கும்போது கூட பயங்கர சொதப்பல். இன்னைக்கு கூட என் ஃப்ரெண்ட்ஸ் கேட்பாங்க, இவ்வளோ அழகா மற்ற செமினார்லாம் நல்லா பண்ணிட்டு அந்த செமினார் ஏன்டா அப்படி பண்ண அப்படின்னு. உண்மையிலே அன்னைக்கு நான் அசிங்கப்பட்டேன். அதுக்கப்புறம் எத்தனையோ பேர் முன்னாடி அசிங்கப்பட்டவொன்னே யோசிச்சேன், இனிமே நான் வந்து ஸ்டேஜ்ல நின்னா எல்லாரும் எனக்கு லிசன் பண்ணணும், இனிமே தான் நம்ம மேக்ஸ் தான் நம்ம அப்படின்னு சொல்லிட்டு ப்ராக்டிஸ், டெய்லி ப்ராக்டிஸ். தப்போ ரைட்டோ பேசுவோம், தப்போ ரைட்டோ பண்ணுவோம். இதெல்லாம் கொஞ்சம் கொஞ்சமா பண்ண பிறகுதான் நாளைக்கு நம்மளால ஒரு பேச முடியுது. ஸோ அந்த மாதிரி ஒரு திங்கிங்கை நீங்க ஏற்படுத்திக்கங்க, சரிங்களா? இது போதும் அப்படின்னு நினைக்கவே நினைக்காதீங்க. எனக்கு வேணும், இன்னும் நிறைய கத்துக்கணும், இன்னும் நிறைய கத்துக்கணும் அப்படின்னு நினைங்க. ஸோ இந்த ஒரு அதை எப்பயுமே மைண்ட்ல வச்சுங்க. அதுக்கப்புறம் தான் இதான் நம்ம ஃபீல்டு ஆன பிறகு அதுல கொஞ்சமாவது ஓரளவு நாங்க வந்திருக்கோம். ஸோ கண்டிப்பா ஐ ஹோப் இந்த செஷன் அட்டென்ட் பண்ணவங்கல இருந்து கண்டிப்பா நிறைய ஒரு ஃபியூச்சர்ல ஒரு கிரேட் மேத்தமெட்டிஷியனா நாங்க பார்க்கலாம்னு நினைக்கிறோம். ஹாப்பி. Thank you so much, madam, for providing this wonderful opportunity to interact with all my students. Further ஏதாவது உங்களுக்கு டவுட்னா கேளுங்க, I am happy to answer.
டவுட்ஸ் இருக்காமா ஸ்டூடெண்ட்ஸ்?
ஃபர்தரா ரிசர்ச் பண்றவங்க போங்க. பிளஸ் இல்லை நான் ஜாப் போறேன் அப்படின்னாக்கா டேட்டா அனாலிஸ்ட்லாம் நிறைய போஸ்டிங் நிறைய இருக்கு சாஃப்ட்வேர் லைன் இந்த பக்கம் வந்தீங்கன்னா. ஸோ பைத்தான்லாம் கற்றுக்குங்க. ஃப்ரீயாக இருக்கிற நேரத்தில் இந்த கொரோனா டைமில் வந்து ஃப்ரீயாக இருப்பீங்க, ஆன்லைனில் பைத்தான் ப்ரோக்ராம் லேர்ன் பண்ணிக்கோங்க. மற்ற ஸ்டாட்டிஸ்டிக்கல் டூல்லாம் ஃப்ரீயாக இருக்கிற நேரத்தில் லேர்ன் பண்ணிக்கோங்க, இதெல்லாம் லேர்ன் பண்ணிக்கோங்க. ஸோ கண்டிப்பாக மேத்ஸ் பீப்புள் நல்ல உங்களுக்கு அனாலிட்டிக்கல் திங்கிங் ப்ளஸ் கொஞ்சம் ப்ரோக்ராமிங் ஸ்கில் இருந்துச்சுன்னா நிறைய விஷயங்கள் நீங்க பண்ணலாம். யூ கேன் டூ வண்டர்ஸ். ஓகே
சார், ஒரு டவுட் சார்.
கேளுமா.
சார், லீனியர் அல்ஜிப்ரா கான்செப்ட் படிக்கிறதுக்கு புக் எந்த புக் சார் ஈஸியா அண்டர்ஸ்டாண்ட் பண்ணலாம் சார்? ஏதாவது புக் நேம் சஜஷன் சொல்றீங்களா சார்?
ஒரு நல்ல புக்குன்னு பாத்தீங்கன்னா நீங்க வந்து ஒரு சைனீஸ் ஆத்தர் இருக்காருமா, அது நல்லா இருக்கு அந்த புக்கு. ஒன்னா நான் வந்து சாஃப்ட் காப்பி நான் சாருக்கு அனுப்பிச்சு விடுறேன். இங்க பாத்தீங்கன்னா எங்க ரெஃபரன்ஸ்ல கொடுத்துருப்பேன் இல்லைங்களா, ரெஃபரன்ஸ்ல கொடுத்துருக்கேன் பாருங்க. என் ஸ்கிரீன் தெரியுதுங்களா?
ஓகே சார். ஓகே.
ஜிங் வாக் லீனியர் அல்ஜிப்ரா, இந்த புக்கு ரொம்ப நல்லா இருக்கும்.
ஓகே சார்.
இதை பேஸ் பண்ணிக்கங்க, இதை யூஸ் பண்ணிக்கங்க. மற்றபடி ஏதாவது இன்ஃபர்மேஷன் இந்த புக்கு நல்லா இருக்குமா?
ஓகே சார். ஓகே சார், தேங்க்யூ சார்.
இது ஆக்சுவலி நிறைய நெட் ப்ரிப்பேர் பண்ற ஸ்டூடெண்ட்ஸும் வந்து இந்த புக்கு யூஸ் பண்றாங்கம்மா. ஜிங் வாக் சன் பியோ ஹாங் லீனியர் அல்ஜிப்ரா. ஸ்கிரீன் தெரியுதா?
விசிபிள் சார், விசிபிள் சார்.
ஓகே ஃபைன். தேங்க்யூ பூஜா. நீங்க எம்எஸ்சிங்களா?
எஸ் சார், நான் எம்எஸ்சி ஃபர்ஸ்ட் எம்எஸ்சி சார்.
குட்மா.
ஃபர்ஸ்ட் இயர்.
தேங்க்யூ. வேற ஏதாவது?
தேங்க்யூ சார்.
முகிலன்? ஓகே மேடம், தேங்க்யூ.
சார் ஓகே சார். ஹரிதா?
Yes, ma'am. It's very kind of you, sir. Thank you, sir. Saying thank you is more than good manners, it is good spirituality. I welcome Miss I. Blessy, first M.Sc Mathematics, to deliver vote of thanks.
Good evening to one and all gathered here. On this wonderful evening, I would like to present the vote of thanks. We take this golden opportunity to thank the respected chief guest of this function, Mr. Dr.A.Felix, for attending this function in his busy schedule. Thank you, sir. I extended my gratitude to the respected our college secretary, principal, vice principal. Thank you, sir. And our head of the department, Mrs. M. Kavita ma'am. Thank you, ma'am. It is my pleasure to thank organizing secretaries. Thank you, sir and ma'am. Last but not least, I thank my fellow students for enthusiastically arranging this function. Without you, this function would not be success. Thank you, my buddies.
Thank you, Blessy. Thank you so much for organizing this wonderful program. Thank you, everyone, for making so many ordinary moments extraordinary. Thank you.
Okay, sir. Thank you, sir. Thank you.
Thank you, ma'am. Thanks a lot.
Thank you. கால் பண்றேன் சார், நான் ஈவினிங் கால் பண்றேன்.
Sure, ma'am.
ஓகே,
Thank you. Thank you.
ஸ்டூடெண்ட்ஸ் லெஃப்ட் ஆயிக்கோங்கம்மா.
Thank you, ma'am.
தேங்க்யூப்பா.
Thank you, ma'am.